Okay, so section 9.3, just finished going over 9.2 questions. We have our integral test, endeavor number 18. We have some conditions, but no matter what, we have an example. We're still going to start by, is he geometric? And the answer is no way, Jose. Does the limit equal of the terms equal something beyond 0? Nope, equals 0, we know nothing. So then, integral. Hold on. To do the integral test, we have to have a few ifs. First of all, if it's continuous. Guys, is it continuous? Yes, because bottom equal to 0, not possible, imaginary, right? So therefore continuous, check. If positive, are all the terms going to be positive? Yes. If decreasing. Is it decreasing? 1/2, 2/5, 3/10. It looks like it's decreasing. How do we know for sure? We could know for sure by taking the derivative and saying, okay, f of x is equal to x over, I'm just trying to show you if you didn't know, like if you couldn't tell. F of x is equal to x squared, or sorry, x over, I take this a sub n and I make it into f of x. So then f prime of x is equal to 1 minus 2x all over x squared plus 1. Which will end up with negative x squared plus 1 all over x squared plus 1. Hey guys, where do the x's start technically?
1.
1 to infinity. So 1, 2, 3, 4, 5, is it negative? Yes. So therefore decreasing, yes. But you could also see it by writing out terms, right? It's going to be getting smaller, 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 and smaller. How do I know that? The limit of the terms is 0. It's going to be getting smaller and smaller and smaller. Okay, so can I use my integral test?
I think if the function is increasing, it's supposed to be divergent.
Let's not make other conclusions. Hold on, integral test. So then I can go ahead and compare. I can compare my series to the integral from 0, not from 0, from 1 in this case, from 1 to infinity of x over x squared plus 1 dx. Can I integrate this, guys?
Yeah.
Mm-hmm. Let me quickly make all this work a little bit. Ooh, undo. A little bit smaller. It's in my way right now. Okay, there we go. Ta-da. Okay, integral test. So I'm going to take the integral from 1 to infinity. How do I do that? I take the integral, the limit as b goes to infinity of 1 to b. Can I take this integral? Is it possible?
Yeah.
Totally. How? Arctangent. U sub. Integration by parts. Which one? U sub. Because I can say u is equal to, which means du is equal to, right? So then I have 1 over u du, but 1/2. So that's going to equal the limit as b goes to infinity of 1/2 ln of x squared plus 1. Do I need absolute value of x squared plus 1? No, always positive. From 1 to b. Does this converge?
Yes.
Yeah, it's good.
Where's b going? Limit as b goes to infinity. Wait a minute. If b is going to infinity, what's ln of going to infinity?
Infinity.
Is it slow? Yes, but is it increasing?
Yeah.
Mm-hmm. So therefore, uh-oh. What is this? from the, or by the integral test. I did my work. I checked geometric, it wasn't, bummer. I checked nth term, limit was 0, bummer. I said, okay, conditions are true, I can do integral test. But what does that tell me?
It's divergent.
By the integral test. Done. By the integral test, since function is continuous, positive, and decreasing, and the integral diverges, therefore the series diverges. Done. Does that make sense, guys? Basically, by us writing this over and over and over again, hopefully for geometric, hopefully for nth term, am I basically trying to get you guys to memorize those tests like none other? Mm-hmm. Mm-hmm. Exactly. We got it? How about this one then? Where would you start? Where should you start? Let's say it's Friday, you have this problem, you should say, ooh, I really hope it's easy and I can do geometric test. So what would you do? 1 over 2 plus 1 over 5 plus 1 over, okay, don't waste time. Is it geometric?
No.
Well, maybe I can do the nth term test. And the nth term test, I can say the limit, n goes to infinity of 1 over, bummer. I know nada. I know nothing. Okay, so he doesn't work, right? So what's my next one to try? Integral test. We'll go quicker on this one. One over n, well, I'm thinking of f of x as being 1 over x squared plus 1, right? That's what I'm considering. Continuous. X squared plus 1 equals 0? Impossible. Check. Positive. Check. Decreasing. Guys, can we look at it? Is it decreasing forever?
Yes.
Decreasing. Let's not take a derivative. Let's just say, okay. Can I use it? Yes. How? Integral. From 1 to infinity of 1 over x squared plus 1 dx. Ooh, that's the limit. As b goes to infinity of 1 to b of 1 over x squared plus 1 dx. U sub, arc trig, integration by parts. Divide, because the top is higher?
No.
Which one? Arc trig. What's 1 over x squared or u squared plus a squared?
Isn't it arc?
Good, arc tangent. What's u? X. What's a? 1. So 1 over 1, arctangent of x over 1 from 1 to b. It's okay? So I can say arctangent, he's back.
Isn't it
Hold on.
5 over 2 minus, what's
Arctan of b minus arctan
of 1?
of 1.
One is square root 2.
Yeah, tan inverse of 1. Tangent is 1 when sine and cosine are the same. Sine and cosine are the same at 45 degrees.
Square root of 2.
Square root of 2 over 2, square root of 2 over
Yeah.
2, which would be pi over 4, right? And what's the limit as b goes to infinity of arctangent? Where's it going? No! Pi over 2. Pi over 2, pi over 2. But long story short, question, does it converge?
Yes, it does. Or converges, yes.
Converges to a number, right? So therefore, I can say by the integral test, since 1 over x squared plus 1 is continuous, positive, decreasing, and the integral from 1 to infinity of now hold on. This is where we could make a big mistake. Can I say what the sum converges to? No. I cannot say what the sum converges to. I can't say pi over 4 is the answer. It's not, but it is showing me the integral is converging. It's not the answer to the series, but it gives me a way to say, hey, he's converging. I don't know to what right now, but he is. Does that make sense? Geometric, I can say what he's converging to. Integral, I just say converging or diverging and done. Not too bad?
I think this chapter will be
I think you're foreseeing that you're going to have a problem and pick a test.
when we learn more tests.
But that's why we're having quiz just 9193. Then we'll have test on, but we will have already quizzed, test on 9195. Then we'll have 9698, no, 9697? I don't know, we'll see.
So it's harder and harder.
Yeah, well, you just think about it. Think, we have geometric test, and then we have nth term test, and then we have integral test, and if none of those work, uh-oh. Wait,
How many more
how would they
tests?
not work? Why would this not work?
Because it's only
Not
positive.
continuous, not positive, not decreasing. If any one of those is false, I can't use it, right? Let's pause just because I want to give you guys more ammo, right?
What does that mean?
Let's cover our last endeavor. Plus, you should be studying endeavors starting tonight and tomorrow, right? Okay, so we'll do our last endeavor for Thursday's quiz and for Friday's quest.
Oh, I remember
Okay.
them talking about this.
Endeavor, P series, yeah. Endeavor number 19. This one is actually a really, really, really good test. Oh yeah, sorry, I get distracted. I don't feel. Full hat. I should play full hat.
Or you don't care.
We'll come back and do some more examples. Maybe I'll mix them up and have us see if we can figure out what to use. Dun, 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 dun. Dun, 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 dun. Actually, you know what, guys? We don't even need another day on this. But I'm sure you don't want a quest on Thursday, huh? You definitely don't want Endeavor quiz tomorrow. What if we get it done here? We do homework tomorrow?
If
Well, I think I might do like a simulation quiz. Like just give you random mixed up ones and have us see if we can do it. That'll probably be Thursday after the Endeavor quiz. Tomorrow, we might just work on homework so that way Thursday you guys can just study homework and quest correction. Maybe. I don't want to slow down too much because even though we're a little ahead, I don't want to lose it. Maybe I'll find some AP questions. That'll be a good idea.
Oh, we are a little
I'll do that.
ahead?
I'll do an AP questions. The problem with AP questions, though, is splitting them up on the tests. Because you don't know all the tests yet, right? So it's like, I'll figure out something. I'll figure out something. Okay, hold on. If P is a constant, what do I mean? What's an example of a P series? 1 over a squared, 1 over a cubed, 1 over a to the 1/2, 1 over a to the, okay. If P is a real constant, then the series, hold on, let's zoom in. What's the series missing? It's missing something, right? Wait a minute.
B equals 1.
A equals 1.
A equals 1.
Right? Because it's 1 to the p, 2 to the p, 3 to the p, 4 to the p, all the way up to n to the p. Well, that's weird. I don't like that. That should be an n. Why are we using a's? Guys, let's just change it to n's. Make that n. N to the p. So messy. I'm sorry. But n's make more sense, right? Isn't that what we're always using? They could use a's, but whatever. Whatever. I sound like Ethan now. What? Okay. If p is a real constant, the series converges if p is greater than 1 and diverges if p... Wait, that's it? That's it. Converges if p is greater than 1 and diverges if p is in between 0 and 1, including 1. What would be some ones that would be diverging? 1/2, 1/3, 3/4, 5/6, right? 1. Hold on, wait a minute. What if p equals 0?
No.
What would that look like? If p equals 0, that would be like the sum from n equals 1 to infinity of 1 over n to the 0. Copy. Anything to the 0 power is just, well, forget that. That just means, right? 1 over 1, which is just 1 plus 1 plus 1. Guys, why would this fail? Why does that diverge? What test could you give me? That diverges. But not p-series test. What test would you use?
Geometric.
You could use geometric and say that r is not between 1 and negative 1. You could use nth term test, right? And you could say the limit as n goes to infinity of 1 is 1, which is not 0, right? So I could say diverges by nth term. Anyway, if it's 0, it doesn't even fit this case. You can prove it different ways, but what if p is less than 0? Give me an example of something less than 0.
So it's
-2? -1/2?
so you can switch.
-4? Yeah, we would switch it. We wouldn't leave it there. We would say, wait, negative exponent. We would say that's n squared. Well, 1 squared plus 2 squared plus 3 squared plus 4 squared. What is that? Diverges. Why?
That one of those special ones.
Nth term test. Limit's not 0. What's limit? Limit of n squared? Infinity. Yeah, I could say nth term again. So they're not including that in this case because there are other ways of dealing with. And you don't normally see negative. That's weird. You would look at it this way. Does that make sense?
Yeah.
So I'm just showing why not 0. Well, 0, that's just 1. That's just constant. That could be geometric. That could be nth term. Either way diverges. Okay, but hold on. Let's get back to the ones that do fit the test. If p is a real constant, the series converges if p is greater than 1, diverges if between 0 and 1, including 1. So,
What was the
oh, sorry,
plus? Oh, nth term.
nth term, sorry. Diverges by nth term, diverges by nth term. Yeah? Good? So, how does logic work for this one? Oh, yes it does. Hold on, geometric. I'm not going to do this for everyone. Let's do it for one. Geometric, what would this be? 2 over 1 plus 2 over 2 plus 2 over 3 plus 2 over 4? Is that geometric?
No.
What's the limit? Ooh, nth term, right? Not geometric, nth term.
So it's here.
Don't know. So hold on, P series. Let me just do this one. P series. Why is it a P series? What's P equal?
1. Wait, I just said
P equals 1. Because it's 2 over n to the 1. Right? Wait, if P equals 1, what do we know by test?
then it wait.
If P equals 1, diverges. I can just say, I'm done. series diverges by P series.
We can-
Technically, since 1, right? 1 is in between or equal to 1 and 0. That's it. Not too bad, right? Maybe? Kiddos, go ahead. Start homework tonight. You don't have to have it finished for tomorrow. We will finish examples tomorrow. We will talk about questions if you get stuck in homework, etc., etc., etc. But be studying what? Be studying those formulas and tests, okay?